Okay, I guess this is go time. So, I would like to thank everybody for coming to see this talk. I didn't know what to expect. So I was talking to people in the front row. Maybe people in the back didn't hear me talking about that. I've never done an NDC before. And I didn't realize, like I thought, oh, there's all these tracks, right? It's gonna be like totally fragmented and like probably not gonna be a lot of people. And then the room packs out. So, oh well. My name is Jeremy Wagner. Hello. I'm an independent web performance consultant, author, and speaker, and I live in Minnesota, which is a lot like Norway. It's very cold. The people are not as nice. We have this thing in Minnesota, it's called Minnesota passive. I totally threw the joke. It's Minnesota nice, but it's more passive aggressive. And like, Norway is like super cool, and I'm so excited to be here. I'm so just psyched to be in a place like Norway. It's really been a fantastic couple days, and I can't wait to see the more of it. So anyway, I'm babbling, so that's how you can tell I'm nervous. So this talk is based on a series of articles that I'm writing for a list apart called eponymously Responsible JavaScript, and part 2 of this series was just released last week, and more parts will be published as the year goes on. I'm definitely doing a 3rd, might do a 4th. Don't think I'll do a 5th unless I could be convinced. That might be going a little too far. So a lot of the stuff you're going to see is a sort of talk rendition of that content. So if you miss some key things in this talk, I mean, for one, slides will be and URLs will be up later at the end of the talk, and I'll post the slide deck and stuff. But if you just kind of want to read the article version of this, the Reader's Digest version, you can check out parts 1 and 2 on a list apart. Quick question: how many people here have actually heard of this article series or have seen it? Awesome. That's actually great. So you all are going to get exposed to this. So I was kind of happy that nobody's heard of it. So a list apart may not be an NDC crowd kind of thing, but it's a great publication. You should definitely check it out. There's tons of great articles. Okay, so to start, I'd like to talk about a word I stumbled on years ago. That word is sfectiousness. And the word itself is unusual in that it's this kind of gold-plated adjective. It's not really easily slipped into a freewheeling conversation. Like, you can't sit down at a pub and be like, that was really sfectious of you. Like, what are you talking about? Like, who's this guy? But it does have relevance in the context of our work. So the word sfectious refers to a set of behaviors which are deterministic and pre-programmed, and it relates, the context of it is in the context of animals and animal behavior. So it refers to repetitive, almost like factory installed behavior, right? Like it's on some kind of instinctual firmware that you can't really update. And it's also a word that's really hard to say if your mouth is numb from a visit to the dentist, or in my case, if you've had a couple of pints and somebody says, hey, say sfectious, and it's like, I don't want to say that right now because I don't think I can. So anyway, the origin of the word sfectious, as you could guess, can be found in the root word sphex, which is a genus of thread-waisted, solitary digging wasps. And I promise you that this is a talk about JavaScript and not entomology, as interesting as entomology might be to me and maybe to some of you out there, although I would not blame anyone for being unenthusiastic about wasps. So digging wasps are, as you would expect, more sfectious than any other creature on Earth, hence sphex. They don't act simply in deterministic or pre-programmed ways. They do that, but they can also be easily manipulated in their deterministic behavior and be totally unaware of it, by the way. So these wasps will provision their larvae with these paralyzed crickets, right? And when they bring the prey back to the nest, they have this weird routine. Before dragging the cricket to the nest, the wasp will leave it outside and then go into the nest to inspect it. And this is behavior that seems like super thoughtful at first. You're like, oh, that's really thoughtful for an insect, but it really is quite mindless. It's totally mindless, as you can tell, because if an observer moves the cricket to another spot before the wasp reemerges, the wasp once again will set the cricket back to where it was before, and it will go back and inspect the nest again. And this cycle can go on and on endlessly. without the WASP ever realizing what's going on until either the WASP or the person gets tired of, or the person perishes. I mean, that could be like a metal album title right there. Anyway, so I didn't come all this way to imply that web developers are mindless. We do know what we're doing. We are not infectious, but there are decisions involved in our work that we make with almost without questioning it sometimes, right? So a good example of this is at the start of developing a new project, we'll open a terminal window, and then we'll install ourselves a familiar framework, and then possibly a client-side router for the framework, and then possibly a state management tool for the framework, of course. And all the while, we're unaware, maybe not unaware of, but perhaps we've even made peace with the overhead that these conveniences bring. And I'm not here to like, crap all over your developer conveniences. Like I use them too, right? Like they help us be more efficient, but we have to think more critically about how we apply these things and when they're appropriate. Incidentally, have you ever opened a node modules folder? Okay. It's a place that if a map was drawn of it in the 1400s, it would have like these fanciful illustrations of sea serpents with stern warnings like, here be dragons, yar. And it's a place we don't go unless we need to. I mean, like if we're debugging a module or something's gone off the rails and you kind of have to like, oh God, it's like, emptying a cistern, but that's not to, I mean, it's not to say we don't know what's in one NPM package, but when you're installing a bunch of them, it's difficult to know what's in all of them and how much. But even so, node modules isn't this black box, even if it seems like it at times. Tools like bundlephobia here can help us to understand not only what's in a package, but also how much it can affect the performance of the stuff that we build. And that's worth knowing because in the last 7 years or so, and before that even, the median amount of JavaScript we serve has increased. And I know you'll have a question about the dip, and I'll answer it after the talk. But half the sites you visit today will send 375 kilobytes or less of JavaScript, and the other half will send more, sometimes a lot more. 25% of websites will send around 650 kilobytes of JavaScript or more, and 10% of websites will serve 1 megabyte or more of compressed JavaScript. Remember that word, compressed, because these graphs are generated from data provided by the HTTP archive, which among other things tracks the transfer size, the over-the-wire size of JavaScript, which is almost, not always, but almost always compressed. And while compression is essential to loading performance, which we know is all important, we all understand loading performance and why that needs to be fast, it doesn't change one simple fact about runtime performance, which is that on arrival, 1 megabyte of compressed JavaScript gets decompressed to 3 megabytes of JavaScript, right? Just assuming a rule of thirds, which browsers must parse, compile, and execute. And that takes time. If you're using high-end devices on low latency and high bandwidth connections, you won't notice this on all but the slowest websites, but that's the bubble we as developers tend to live in. I mean, a lot of us have high-end devices, and unless we're performance-minded, and a lot of us are. I'm kind of a performance specialist, so I'm a little obsessive about it. But unless you're performance-minded, you're not going to really take notice of this problem until it begins to affect you personally, or it can be made real to you in some way, and that's just human behavior. But on median mobile hardware, such as this affordable but slower Moto G4 Android phone, chewing through megabytes of JavaScript makes for a really frustrating experience, and I would recommend to anybody to go on to Amazon or wherever you buy things and buy yourself a cheap Android phone. I have one at home. It's an Android Go it's an Android Go phone. It's a Nokia 2, and it's a real exercise in patience. And it's easy to brush aside the long tail of devices of like that Moto G4 and assume that those who use what we make are on high-end devices, and a good chunk of them may well be. But the bigger picture of the devices accessing the web tends to be different than the assumptions we make, right? For example, take this graph based on analytics from a blog I host for a friend on guitars and related accessories. This site receives significant traffic from mobile devices all over the world with a very long tail of unusual or not typical devices that I couldn't fit individually on this graph. And you can see it's under Other Android. So that long tail is something you need to pay attention to because when either devices or networks or both are slow, the web becomes less usable and more frustrating. And at the bottom of this web page test timeline is a main thread activity indicator. When it's green, the user is able to interact with the page, but when it's red, the device is unable to do anything. Can't do anything. The main thread is totally occupied, browser FPS is cratered to 0, and users are waiting for a hanging device to respond. The device is unusable in this case for 2, 4, sometimes even 6 seconds at a time, and you pair that with a slow network, and you can imagine how tiresome the web really becomes to use on this sort of median mobile hardware when we're serving just buckets of JavaScript. So we're not building collectively. I'm not like saying you, I'm saying collectively, a lot of us just aren't building a lot of experiences that can work in all of the places they might need to. And understanding constraints is key to writing good software. Some of the best video games ever made were 1 megabyte. A lot of times, depending on the platform, like NES games, far less than that. And these people who created these games had a lot of vision, as we have a lot of vision for the things that we want to do. And they understood the constraints that they needed to work within. But their constraints, to be fair to us, their constraints were fixed to the systems that they produced games for. If you made an SNES game, everybody basically had an SNES, right? That was the constraint. It was very like, everybody has one, this is what we know. Our constraints are not fixed. They can be wildly different from person to person. In a way, that makes our job much more difficult than their job. Even if their work is more memorable, our work is harder, way harder to do. But that doesn't mean we can't make truly great experiences on the web that work for everyone and everywhere. So let's talk about how we can turn that speciousness into anti-speciousness for the good of the web and for the people who use what we choose to put on it. All right, there's a wonderful expression I came across this year a little while ago. It goes, paint the picture, not the frame. It comes from an article by Eric Bailey about accessibility and UX. It's another a list apart article. You can tell I have my preferences for my publications. The implication of paint the picture, not the frame, is that we should focus on what we want our websites to do for people, right? And that we should not subvert their expectations for how things should work by changing externally consistent behaviors. And external consistency is something we expect in many facets of our lives, like down to like the fixtures in our houses, the light switches, the faucets, things like that. An example of when, at least on the web, of when external consistency is disrupted might be a website that changes the appearance of a scroll bar in a way that isn't consistent with a person's expectations. That may be a decision that impedes people in ways we didn't expect. Or, perhaps more importantly, how when we fail to use semantic HTML, we create experiences that are difficult for those who rely on assistive technology. So this isn't just a performance thing, it's also kind of an accessibility thing when I talk about responsible JavaScript. So paint the picture, not the frame is also this really wry way of saying that we shouldn't reinvent things the browser already does very well, like buttons and forms, right? And more often than not, those things need to just be, just need to be used correctly, or in some cases just need to be used in the first place. So I apologize for this because I know it's not exactly the most readable, but there will be a video and I will put the slide deck up. But this is a example email subscription sign up React component, right? Looks probably pretty familiar if you're into React and you do that thing. The email sign up form is a stateful component that has one field, a label for that field, and a submit button. And they're all constrained within one div. Now, I'm sure you have some very strong opinions about what's wrong with this code, provided it's readable, depending on the distance, and I apologize. But what I will tell you is that the solution to what might be wrong with this doesn't require more JavaScript. It actually requires quite a bit less. So let's dig in and take a look at this form JSX. There are three big things that are wrong here. And the first one is that a form is not a form unless it uses a form tag. And divs are not intrinsically flawed. They lack semantic meaning by design. They're supposed to be that way. They're conveniences for us for structuring markup. But this is a form. Forms should always use a form element. Okay? All right? Now I feel like I'm like really lecturing, so I'm sorry. I'm American. I'm sorry. But this is a form, okay? And when we label form fields, a label element should be used with a for attribute that corresponds to an ID on an input element. And that's important because it lets assistive technologies know that a label corresponds to a specific input. And tying labels to inputs with semantic HTML actually helps all people interact better with forms, not just those on assistive technology. You can click on a label element and make that hit area for that field much bigger. It actually, reduces the chance that you're going to miss that. So it's actually a good thing to do for everyone. And 3, while divs can be coded and styled to behave, and so on to look like buttons, don't do that. Doing so robs a button of any semantic meaning it would otherwise have if it was just a button. And here's a bonus. A button element's default behavior within a form element is to submit that form. And this makes it more fault tolerant for a more fault tolerant solution for when, not if, JavaScript fails to run, because your JavaScript might run really well most places, but there might be somebody who's behind some weird proxy or whatever, and if it totally depends on JavaScript, it's gonna break, buddy. It's just gonna break. So now let's look at this JSX if it were refactored to be more accessible. This is the refactored form markup, and every part of it now has semantic meaning that assistive technologies can use, which means it's more helpful to people. And also, it will continue to work if JavaScript is unavailable, assuming, of course, that the component is rendered on the server. So that's kind of an important part. Also note how the submit event handler has been moved to from the button's on-click event to the form's on-submit event. And this is helpful for when we want to intercept a form's submit event if we want to enhance this form's behavior with client-side JavaScript, if we want to layer on, right? And additionally, we removed the validate email function. We used an email input type in combination with a required attribute to leverage the browser's own email field validation, which most browsers, like 97% of browsers in the wild, do this, including IE11, I believe. Now, here's the final component code in its entirety, which we refactored from a stateful component to a stateless component. And there's a performance boost here because stateless components don't extend React's component class. They're not classes at all. It's just like a closure, like a function or like an arrow function. And what's good about this is that the transpiled and optimized output for this component will now be significantly smaller, usually like 1 to 1.5K per component. If you have a lot of components, it's worth going through and like refactoring and like removing, if it doesn't use lifecycle methods or state, it's worth refactoring. And additionally, because email validation is now handled on the client, we can remove JavaScript, the JavaScript that once did this for us. The vast majority of browsers already provide this functionality. And of course, should always sanitize your inputs on the server. I'm not saying rely on the client alone to validate your input. We all know that's probably not a good thing. But where possible, you should move your front-end validation logic to the server rather than forcing the client to load code to do something that the browser can already do for us on the client. And of course, external consistency and semantics aren't strictly limited to HTML and CSS and JavaScript. We expect browsers themselves to behave in certain ways. And one of the most common subversions of expected browser behaviors is the single page application, or the SPA. And now I might be wandering into dangerous territory just saying what I just said. But as a disclaimer, my personal inclination is to avoid building sites as SPAs. And this isn't because I hate them, or I don't personally benefit from them in the apps that I use, or I don't understand them, or don't even think that they could be beneficial. It's just that, well, the navigation behavior they replace is one that browsers already do so well. And it's a problem that's been thought of and solved by browser vendors very thoughtfully, very carefully, even if synchronously, even if that navigation is synchronous. And loading a client-side router can be begging for trouble. Because when we re-implement navigation behavior in JavaScript, accessibility can become a casualty in that effort. There's a whole host of things that we end up reinventing, or worse yet, we miss them all together. History must be managed, tab index and scrolling position must be accounted for, navigation canceling can fail, and so on. There's probably a bunch of stuff here that if I dived into the spec, I could come up with a whole laundry list of things that you have to think about. And so even if we get client-side routing just absolutely perfect, rendering performance is affected if that content is not first by the server. If you have the client do everything, there's going to be some a little bit of weight in here. Think there might be a spinner there, but a spinner is not really meaningful other than to tell people, hang on, something's coming. And furthermore, when we fail to send markup on the server, the content of the app is potentially inaccessible if, and remember, sometimes when JavaScript fails to run. When we serve content from the server, I'll concede. We lose a bit of snappiness, but we regain that external consistency that people expect out of browsers. And that's not to say that we can never use client-side routers. If you provide server-side versions of all your client-side routes, people will have a way at least to access any part of your site as long as they have a network connection or service worker. And then, if components are attached to server-side markup, a process known as client-side hydration, people receive a progressively enhanced experience, and that's really good. That gives us the freedom to try different things. For example, perhaps only the authenticated portion of your app can be a single-page application, and the unauthenticated portions can be normal synchronous navigation. Or you could design your application, and I like this idea, I'm experimenting with it a little bit. You can design your application so that people could opt into client-side routing without making any assumptions. You give them the externally consistent behaviors by default, and if they want it, maybe they can opt into it in account preferences or something like that. Or you could try something like link prefetching, which is possible with the markup shown here. Link prefetching can seriously boost loading performance and navigation performance because you're fetching page HTML, you're fetching documents in advance. This prefetching is also done on a low priority thread, so it doesn't contend for bandwidth with other resources while the page is loading. It's not going to slow other things down, especially if you wait till after the load event to do these things. But it's not perfect. I concede if you've played with link prefetching, you know that it can potentially waste people's data, and that's something to be mindful of. But it does provide a nearly instantaneous navigation experience as people go from page to page, whether it's pages on your server or elsewhere on the web, which is cool. But to address the possibility of wasted data, the Google Chrome team offers a really small library for prefetching pages as they scroll into the viewport. And it only does so when the main browser thread is idle, if network quality is good, and if the user hasn't stated a preference for reduced data usage using Chrome's data saver feature. But that's still too risky. One solution I've come up with is a very small script called DNStradamus, which prefetches DNS information for outbound links as they scroll into the viewport. So doesn't go as far as loading a document, but it'll do that DNS lookup speculatively and reduce that a little bit. I'm thinking about adding some pre-connect stuff into it later. It's not as effective as link prefetching, but it is less risky since DNS lookups are fairly small. For example, Cloudflare's public DNS resolver issues request packets over UDP that are under half a kilobyte usually. So it's pretty small, pretty cheap speculation, and this script is compressed as 600 bytes or something. So while we're on the subject of wasted data, one of the biggest offenders are images that load but go unseen, and it's such a problem that we often lean on JavaScript to lazy load this content. Think images and video and iframes and all that stuff. And most lazy loaders are actually really quite small. I have a solution called y'all.js, which is the most southern thing I've ever said, y'all.js. For example, is roughly 1.5 kilobytes uncompressed, though some alternatives can be quite a bit bigger. But regardless of size, no JavaScript solution can be as robust as a native browser solution. To wit, Chrome has recently shipped native lazy loading, and native lazy loading adds an additional loading attribute to image and iframe elements. It takes one of three values. It's auto, eager, and lazy. And auto does what Chrome did prior to native lazy loading, and which basically means it'll load them normally. It's the default. But if browser heuristics are optimized in the future, they may intelligently defer the loading of assets depending on network conditions. It might not be something they're doing now, but it's a possibility. It's something that might happen. A setting of eager, though, will ensure that the content is loaded no matter what on page, like as soon as it's requested. And of course, a setting of lazy shown here ensures that the content, the image or the iframe, is loaded lazily. And so when the loading attribute is set to lazy for images, Chrome will issue a range request for the first 2 kilobytes of an image. And it does that so it can get the dimensions of that image so it can properly size the image placeholder so you don't get that horrible jumpy layout, like you're gonna tap and then like it moves, so that won't happen. And then the content is loaded in full as it nears the viewport, as lazy loading tends to do. So because not every browser supports this, some work is necessary to make sure that all browsers get a similar experience. But you could conclude that only browsers that support native lazy loading should receive that benefit, while others get a less enhanced but still perfectly functional experience. And that's progressive enhancement at its core. It's a fine decision. I actually like it. If I was building a new app, I might actually just consider letting browsers that don't support it just that's what they get. But you may already be lazy loading images with JavaScript, so you're going to want to retain those benefits, right? You don't want to take something away from somebody who has already been benefiting from it, like they're using Firefox, and you want to make sure that they still get the good stuff. So this markup shows how the common data attribute pattern used by many JavaScript lazy loading solutions can coexist in the same element with the loading attribute. Unfortunately, in this case, the placeholder will be lazy loaded, not the final image sources as we expect. So we have to do some feature checking, and you can see here if we check the HTML image elements, HTML image element objects prototype for the loading attribute, we can decide what we want to do, if native lazy loading is a thing or if it's not. And if we can use native lazy loading, we can find all the image elements with a loading attribute value of lazy and immediately populate the proper source or src set attributes with the final sources and just let the browser do its native lazy loading thing. If we can't, though, then we can fall back to a native lazy loading solution. We could dynamically import if we wanted to not load that uselessly for browsers that support native lazy loading. Of course, these things are always more complex than what they first seem. So if you're involving stuff like picture elements, or like you're trying to like lazy load video, which is not a candidate for native lazy loading yet, it gets really kind of weird, especially when you start mixing in all these different image sizes and image candidates and stuff. So fortunately, the Smashing Magazine article on Hybridized lazy loading by Andrea Verlici shows you how you can manage both of these things, both native and JavaScript lazy loading, with thought and care. So I may seem like I'm droning on and on about the stuff that the browser gives us for free, but the point remains. The browser does give us a lot for free. So let's use that free stuff whenever we can. We like free stuff at conferences. Let's use browser free stuff, right? So we can focus on the harder problems, right, of web development, the really hard stuff. Now, JavaScript isn't to blame for the woes of the web. It's how we use JavaScript. So, and how the responsible use of it starts with understanding one idea, and that is the tools are not infallible. The tools don't do the work for you. And they do some of it, but you still have to make some critical decisions, right? Very few things are rarely set and forget. There's one tool many of us depend on when we need JavaScript, the ES6 that we write, to work everywhere, and that tool is Babel. And while we realize and appreciate everything Babel does for us, we sometimes fail to see the things it can do to harm performance. And Babel is not something to idly slap into projects, so even though we do that sometimes, I've done it, but we have to know how it works with the ES6 that we write. And we have to know how to configure it best for our applications. While we benefit from Babel's defaults, they may not always produce code that's optimal for our constraints, like your constraints, my constraints, everyone. And these defaults are designed to be safe, but not necessarily the most optimal. Those who use what we put on the web benefit from Babel because it broadens the compatibility and the reach of our apps. We can reach more people, provide reasonably similar experiences across platforms. But those users would benefit if we could transpile less code. because the way Babel transpiles or transforms our source code sometimes adds more to our production code than we might realize. So let's take this example logger function, which accepts a message and a level parameter that gets passed to the console object. The second parameter specifies the log level. This corresponds to a console method like log, warn, or error. The default is log. Default parameters are very convenient, but Babel often transforms them with excessive amounts of code. And on top of that, this transform is repeated in every instance a default parameter is used. So if you use them a lot in your client-side code, there's an opportunity right there to ship less JavaScript. And I can't, if we can't avoid Babel altogether, and we can't always, JSX, right? We should consider compensating for stuff like this if performance is a real, a big priority. And this is especially true if we're writing libraries that people install. Like if people are mass consuming, like with y'all.js, a fair amount of people install it, I've noticed. And I'm like, okay, let's see what I can do to get that as teeny tiny as possible, because I want everyone to benefit from that as much as possible. We can mitigate this transpilation cost by removing the default parameter, and you just replace it with an OR check. So when a parameter is omitted at call time, the value of that parameter is undefined. It makes sense. So when we want to assign a default to an optional parameter, we perform a check where the left side of the OR is the parameter itself and the right side is the default. Now this means that if the parameter is not supplied, the right side of the OR condition is used, which is the default. But this isn't bulletproof. If you have a parameter whose default is like truthy or Boolean true, you might have to do like a ternary or like an in type operator thing to perform a different kind of check, because if you supply a falsy or Boolean false value, the default will always take precedence if the default is true. So not to harp on that, there's just one such parameter, it's one such feature that gets transpiled by Babel. In some environments, it transpiles ES6 classes too, and those are great. It's in my opinion, some people have beef with them. I like them. I think it's a reasonable amount of sugar to turn that prototype pattern into something that more closely resembles classes as they exist in other languages. But they have a cost, and if you can't read it, don't worry. It's not really important for you to read it. It's just know that's a lot of code for an ES6 class transpilation. And as you can see, there's a lot of that code so it can run everywhere. And if you want to mitigate this, you have a couple options. You could use the prototype pattern. Okay, I mean, if you're really familiar with it, maybe that's the way to go. Or you could use Babel runtime in concert with like Babel plugin transform runtime, which can deduplicate some of this code and some of the helpers that Babel adds. Or 3, if your list of supported platforms is limited to like modern evergreen browsers, you could remove Babel altogether from your tool chain. And if you can do this, that's probably your best option. However, if your app makes use of JSX, you kind of gotta need like something to transpile that syntax, because JSX isn't supported by browsers. So it's how we write our ES6 isn't the only thing to consider though when we use Babel. We have to know how to configure it. And suboptimal Babel configurations are tough, because even if you're experienced in using it and there's a lot to miss, there's just a lot to miss, or you could misunderstand something. And polyfilling is something we use Babel a lot for. I mean, if you're familiar with Babel preset env, this snippet may look a little familiar, but it is worth taking a second look at this use built-ins option, which we use in concert with core.js to polyfill features which are based on a browser's list query. When this option is set to entry, we have to ensure that core.js itself is an entry point in our app. And doing this adds more polyfills to production code than we might need. And you can see here that the main bundle of this example app is about 117K. You're thinking, it's not that big. Yeah, you're right, it's not that big as far as apps go, but the majority of it is polyfills. So if we make a simple change and we change the value of use built-ins from entry to usage, we're ensuring that Babel only adds polyfills based on the features that it detects in the code that we write. So depending on your project, this could have a profound effect on how much JavaScript you ship. In the case of the example app, we go from 117K down to about 68.5K, and that's like a 40% reduction from a one-line change. There's another configuration flag in preset env that deserves our attention, which activates something called loose mode. Loose mode is when Babel takes your ES6 and applies transforms to it that adhere less strictly to ECMAScript's standards. And because the transforms aren't spec compliant, they're quite a bit smaller, and they will still work in most situations. And loose transforms can be applied by enabling the loose flag, which is false by default. Here's an example app where loose transforms aren't enabled. Same as before, 68.5K. Could be smaller though. Now here's that same app with loose transforms enabled. It's 18% smaller, and the app still works as before, although it'll be a touch faster now. But loose mode isn't bulletproof. This post by Axel Rauschmeier advises against them. But whether that advice pertains to your project really just depends, right? The criticism against loose mode is that if you move from like transpiled ES6 code to untranspiled ES6 later on, like you pull Babel out, you could have some compatibility issues. But in my opinion, if the savings are worth it, you can always tackle these potential issues in a sprint like later on, if you decide later on you want to drop Babel. Chances are good though that you'll be using Babel for some time as JavaScript continues to evolve. And if you're using JSX, you're not very likely to really pull that out of your tool chain. Another way to serve less code to users involves a technique called differential serving. And it's a method of serving one of two bundles to your users based on their browser and their capabilities. Bundle 1 would be for those on legacy browsers. That's the one you're probably already shipping to every browser. It contains all the transforms and the polyfills necessary for your stuff to run everywhere. But bundle 2 would be for those on modern browsers, these evergreen, nice pine-smelling browsers that update themselves. This bundle would have little to no transforms or polyfills depending on what language features you're using. And the benefit is that sites loaded on modern browsers will be able to function with substantially less code and not sacrifice any features. It's just simply reducing the amount of code by applying less transforms to it. So of course, we need a way to load these separate bundles. And what you see here is the way we've always loaded JavaScript. This pattern shown here is how we can differentially load JavaScript though. The first script tag loads a bundle meant for modern browsers, and adding type equals module means this script will get picked up by modern browsers. And because legacy browsers don't understand that type attribute value, in theory, and I'll come back to this, in theory, they'll ignore it. The second script tag shows how we would load the legacy bundle. And what you see here is the no module attribute. It isn't understood by legacy browsers, so they just go, oh, whatever, and they just gloss over it, and they just download the stuff anyway. But no module is understood by modern browsers, which will decline to download scripts that bear that attribute. Now, configuring your toolchain to differentially serve code is another matter altogether, but it's doable. You'll need to create two separate Babel configs, one for each bundle you intend to generate. And this Babel configuration here shows a typical config like you'd see in a lot of projects. We're targeting older browsers. We've specified use built-in usage to selectively add polyfills we need. Now this is a configuration for generating bundles for modern browsers. And you'll notice that use built-ins is gone. That's because this configuration would be for a project which needs no polyfills because modern browsers don't need them. The code base in this case it's using features that already exist in modern browsers, therefore they don't need to be polyfilled. And we've removed the browsers list query and instead supplied an option named ES modules set to true. And under the hood, what this does is this translates to a browsers list query string that includes all browsers which understand ES6 modules, and that's super convenient because if a browser supports ES6 modules, it also supports other modern features. Think stuff like async await, arrow functions, spread syntax, all that good stuff. And then here's how both of these configurations can live together. Babel allows us to group multiple configs under an env object. In our bundler configuration, we can point to these separate configurations. So in Webpack, this is probably how you use Babel Loader to match scripts to ensure that they get processed. Now note the env name setting. This points directly to the configuration in the env object from the previous slide. And then using Webpack's multi-compiler mode, which just allows you to export multiple configurations in an array, you can create a wholly separate config to generate a modern version of your bundled code. And then in the modern fork of your Webpack config, you can then point to the client modern Babel config to generate a smaller version of that code for modern browsers. And the size differences between legacy and modern bundles depends on the project. Some projects may only see marginal gains to the tune of like 5 to 10%. Some projects may see much bigger gains. For example, we applied it to some components at a client for mine. Some of them were reduced by almost 90%. That's atypical. I would say more often than not, it's like between 30 and 50% with no change in functionality. This is a Webpack bundle analysis of an example app's legacy bundle. and it's already pretty small at around 68K. It's the same one I've been showing. But with differential serving, we can go from small to like nano, like teeny tiny, and deliver this app to modern browsers in like just 40% of the size of its legacy counterpart. 40% of the size. Like, you can just get that for free. It's free. I mean, wouldn't you do that at your job? That's pretty awesome. And even better, when we serve scripts with type equals module, this is the fun part. We're in Chrome, at least, we're invoking a stricter and therefore faster parser, JavaScript parser. And this means that you're not only shipping less code, but you're shipping a version of it that Chrome will like rip through a little bit more quickly, because stricter parsers are less tolerant of errors. It doesn't have to like spend time trying to compensate for things that you might have messed up, and it'll chew through it a little bit quicker, and that's great. But remember that type equals module, no module pattern we talked about? Turns out in IE and Edge up to version 18, although not in the new version, which is now Chromium, and then some versions of Safari, although not the latest versions of Safari, there's a little bit of a problem. Depending on the browser, both bundles can be downloaded, and in the worst case scenario, both bundles can also be parsed, compiled, and executed. You're like, thanks a lot, Jeremy. Thanks for nothing. You've got my hopes up and you dashed them. Well, okay, hang on. This is where you have to make a judgment call. Perhaps the majority of your users are on modern browsers, and you might just think, well, maybe I don't care about like IE11 anymore. Maybe I just don't care about it. Maybe you allow them to take the hit. Or do you try to find a workaround so that everybody gets the most optimal experience that they can possibly get? Well, it's your app, so it's your call. But if double downloads are unacceptable to you, and they are unacceptable to me, there's another way, though it is a workaround. It's not a nice standard-y type solution. In this workaround, you can create a script element and infer type equals module support by checking to see if the browser supports the no module attribute. And if it does, we can inject a script that points to a modern bundle. If it doesn't, we can inject a script that points to a legacy bundle. And I've used this pattern for a recent client of mine, which is a large electronics retailer, and it ensures scripts get delivered without double downloads, and it's working in production right now pretty well. This is important for them because their in-store kiosks use IE11, and it will continue to for this foreseeable future. For them, performance is crucial in this setting, so it was just double downloads and potential double parsing was just not an acceptable outcome for them. So we found a way to solve that, and everyone's happy, and less JavaScript, yay! So, of course, I can't do all this talking about first-party JavaScript without mentioning third-party JavaScript, at least, for a minute. And third-party JavaScript is like a huge problem. And for some, it's a bigger problem than our app code. And this is a visualization by Patrick Hulse, I hope I said his name correctly, of the performance impact of third-party code grouped by organization. And this analysis is done on data gathered from the HTTP archive, which tracks data and performance data for like 4 million origins and sites. And the message here is simple. Every third-party utility, advertising partner, tag manager, and so on, and so on, and so on, has a performance cost. And aside from the overhead that third parties add, one of the most damaging things that they do to performance is that every unique origin requires a separate connection to be open to it. And this is a 3-part process. You have to do DNS lookup to find a server IP. Connection then has to be opened up. I mean, if it's over UDP on quick, that's pretty fast, or HTTP3 that they call it now. That's pretty quick. It's not horrible, but like the web is still a lot of TCP, and that takes a while. And most of the time, we have to open a TLS connection because security. That's practically the default now. I rarely see unsecured stuff in the wild anymore. And this latency adds up to a lot of time people spend waiting for pages to become interactive. And the more third parties we add to sites, the more that this is felt, the more that this is multiplied. And if you want to get a quick idea of how many third-party servers are part of your overall performance picture, you can go in the network panel in Chrome DevTools, and you can filter out by domain. So in this case, like in CNN, we just filter out all of the non-CNN.com domains. And you can also turn on third-party badging. As you can see, gpt.js has this little DC. It means it's from DoubleClick, Google's ad serving program. It helps you identify these things a little bit more easily. And using Google Fonts as an example, here's how a single third party can impact performance. In this web page test timeline, a relatively small site is being held up from fully loading and painting text because the browser is forced to wait while fonts download from Google Fonts. And you'll notice that DNS, TCP, and TLS time for 2 domains really holds up the show. Fonts don't begin to download until like 4.5 seconds in, and they finish at over 5.5 seconds. And for a small site, that's a really long time to be waiting for web fonts, which block the rendering of text by default. It means people can't even read anything. And then the solution here to this is to self-host if you can. When you self-host third-party resources, you eliminate connection latency to other origins by eliminating them entirely. Here you can see that the only connection we open is to the primary origin. And this is one we can't avoid. I mean, your stuff has to live somewhere, right? But by cutting Google Fonts out of the picture and self-hosting those resources, we can get fonts downloaded on the client inside of 3.5 seconds, and that's a big improvement. And aside from auditing your third-party code and eliminating what you truly don't need, and you should be doing that, you can extend the idea of self-hosting third-party assets to most things, and the benefits of doing this are huge, especially where JavaScript is concerned. Optimizely is a very popular client-side A/B testing framework. I'm not crazy about it, but my clients use it, and it's clearly useful to them. I think it would be ideal to do server-side A/B testing instead, but that's not always possible. And so in this case study, Casper Mattress was able to reduce start time by 1.7, or start render time by 1.7 seconds by self-hosting Optimizely's JavaScript. It was an involved process to accomplish this, but the results were clearly worth it to them because it's money for them, right? The sooner we can get this loading, it's money, money, money. And so self-host as much of that third-party code as you reasonably can, but if you can't, you can do resource hints. You could like do DNS prefetch to do a look ahead on a third-party host, or a pre-connect to actually initiate an early connection to a host, and you would put this in your HTML head well before the browser would ever discover those resources. It's not as good as self-hosting those assets, but it does take some of the sting out of that, and it's a relatively easy thing to do. And of course, this leads us into a discussion about what it means to be accommodating. When we deploy something to the web, we have to be a steward of that thing, right? And we have to try our level best to make it as usable for as many people as possible. Because you don't know who's going to access it. You don't know who's going to find your content useful. You don't know who wants to get your product, right? So in the United States, many developers live in large cities, which are typically well served by low latency, high bandwidth broadband connections, and mobile internet connections like LTE and coming up 5G. But a large portion of the country's population lives in remote or underserved areas where this just isn't the case. And this article by the MIT Technology Review revealed that 58% of households in the Cleveland metropolitan area with incomes under $20,000 a year had no broadband access at all. And these are people who rely on like mobile internet connections with like data caps, right? And they need this because we're becoming an increasingly internet-dependent society. I mean, it's a requirement of living almost. Should be like a human right. But even more striking is this passage where Pew Research finds that fully 1/3 of Americans don't have an internet connection faster than dial-up in their own homes. Like, think about that. I doubt this was written in late 2016. I highly doubt this has improved significantly since this article was written. The infrastructure just isn't there yet to bring these people into the 21st century. This is a broadband map of Buffalo County, Wisconsin, the state just east of where I live in Minnesota. It is a microcosm of what rural broadband is like in America. And if you happen to live near a population center and have the money, broadband is an option for you. But once you start getting out in the sticks, broadband starts to look less and less like an option until in some places it's just not an option at all. So the two foundational elements of network performance are latency and bandwidth. So if you're serving a lot of assets in your site, sufficiently high latency or low bandwidth makes your site functionally inaccessible. Thankfully, there's a technology supported in Chrome, which is used by well, I wouldn't say the vast, but like a very large majority of users on the web. And this technology is called client hints. Client hints are a feature that help developers to know the characteristics of both a person's device and the network that it's connected to. And there are a lot of client hints, a lot of them, but there are 3 I feel that are really useful that I want to talk about today a little bit, and that's RTT, downlink, and ECT. RTT, or round trip time, is the approximate latency a user is experiencing in milliseconds. Downlink, as you might guess, is the approximate downstream bandwidth in kilobits per second. And ECT, or effective connection type as it stands for, is an enumerated string determined by the browser after it evaluates the RTT and the downlink values, and then tries to coarsely categorize the speed of a connection, with 4G being the highest. Now, that doesn't necessarily mean it correlates to 4G. It just means this is at least as fast as what we think 4G should be. So it could be like cable, could be like fiber. But it's useful, right? It attempts to categorize this, and that's useful for us because all of these hints can help us to tailor experiences to send less stuff to people on slow connections. We can opt into specific hints with the accept ch HTTP request header. And you can see here, those are the hints we want to opt into, separated by commas. And we can tell the client how long we want these hints to be accessible to the client with accept ch lifetime. In the above example, we persist these client hints for a day, but you can supply whatever works, right? Like a long value is not going to be harmful. So you can access these hints in a server-side language or like in a service worker even, like PHP as we see here. And when they come through as request headers. And here you can see that we initialize this variable with the default of 4G. And we do this in case a browser comes along that doesn't support client hints. So they'll be assumed like the fastest connection speed. We do this because we want to deliver the ideal experience to people who don't support client hints because we just don't know, right? Then we check to see if the ECT hint has been sent as a request header. And if it has, we store that header's value in the ECT variable. And using this information, we can shape experiences. We can adapt them to the shifting conditions of the network or even the device accessing them, because there are device-specific things like device memory. You could decide, I want to send less JavaScript if a device only has a gig of memory, right? That's useful. Parsing and compiling and executing takes memory and processing. So this is a powerful technology. You can create lighter, more focused experiences for people who need it the most. And in the example above, we decide that a person will only see a data-intensive carousel if they're on a reasonably fast connection. And if a user is on a slow connection, we lighten the experience for them, and the focus is increased on content that's critical to them. This is, by the way, this is easy to sell to product stakeholders because everybody gets what they want, right? Because most people are reasonable. They want to help people out. You'd be like, well, the default could be the ideal, but maybe we could like check for slower connections and maybe adapt it a little bit. And this works. I like to call this adaptive performance. I think it's a fantastic way of compromising between the ideal that you wanted to build and what the user needs in order to use the thing that you put out there. And it works. Here are two versions of the same site. It's a central Wisconsin logging company. I sort of anonymized it. It's actually, the client name is different, and so they're not actually called Sky Timber. The version on the left has like custom fonts and a carousel and like accordions for like a Q&A and a lot of JavaScript to run all of this stuff. But it's pretty much inaccessible for people on a slow connection, and their clients live in like the middle of nowhere, like Wisconsin. Like, it's really difficult in some of those spaces for them to access this. 90 seconds on 2G. But using client hints, we can distill this experience, as you see on the right, for those who are on slow connections. We can remove those things that may not be as crucial to like what users need, the information that they need. And for our trouble, those people will have something they can access quickly, even if bandwidth is lacking and latency is very high. We're talking like what, 5 requests, 12 kilobytes, it's like 5 seconds over 2G. If you're used to a slow experience, 5 seconds is reasonably snappy, right? I get throttled every time I traffic, and I'm just sitting here in Norway going, come on, come on. I wish everyone was using client hints. So, if you're interested in knowing more, I did a talk at Full Stack Fest in Barcelona last year that goes into this like in depth. It's all the client hints and all the stuff about it. You can check that out. But if you're not into videos, I'm more of like a person that likes to like kind of digest stuff at my own pace and read articles. I did write an article for Google Web Fundamentals about it, and it goes into a similar depth. Okay. So in closing, I want to hit on what I think is an important point, and that is we need to first understand what it is that people want from what we're putting on the web. Meaning, what do we want them to do when they get to a given website? What's our goal? How can we help them? And then we need to work backward from that. We shouldn't front load some of our assumptions that our architecture with like all of these tools, assuming that these tools are going to give us like the best result. We have to think about what the user wants and work backward and decide what the appropriate path is. And that would be a good thing if we would do more of that. But as I understand, any person in almost any profession just loves their tools, and I get it. I love tools. They're great. They allow us to build things like that, faster and like more complex and all that kind of stuff. But like, unlike the auto mechanic who works in your car, the tools we choose to do the work, at least the production dependencies we choose to use, have a direct and felt impact. Like they're sort of bundled in and the user has to like bear the cost of those tools. Like the mechanic doesn't throw a ton of wrenches in the back of my car when he's done. I don't feel that. But like we feel it like as users when we use too much of this stuff. We don't always need to burden them with the entire tool chest or the whole tool shed even. Sometimes it makes more sense to like step back and use tools that are smaller and more focused on the work. And that is to say that your experience as a developer is important. I agree with that. I don't want you to think I'm like crapping on all of the stuff that we use. That stuff is important, but it is never more important than the user experience. That's the purpose you need to serve, is the user experience. And if your excitement for a certain set of tools causes you to build things that no longer amicably and effectively serve those purposes, it's high time to reevaluate them. Look at your analytics, find out where your users are coming from. Get a real user metrics library and find out how people are accessing your site, like real people, what are their impacts, and start making changes. But thankfully, the ecosystem gives us a lot of options without sacrificing developer experience entirely. You can always find smaller options that will be felt less by the people who use what you create. I'm a big fan of Preact, by the way. It is almost 100% API compatible with React. New version is going to be using hooks and all that stuff that we like, and it's a tenth of the size. And that's huge, right? And you can always add React later on if you needed to. But time and time again, if you look, you can find alternatives to commonly used libraries and frameworks. And so hopefully you can use less JavaScript, use it more responsibly and with care. My fervent hope is that over time, we can learn to do more with less JavaScript. And this may be a fool's hope, or maybe even recognize when we don't need JavaScript. So we can create resilient, fault-tolerant sites that are faster and more accessible for everyone, everywhere, because that's what people deserve. Thank you. Smooth move. I dribbled all over myself. So we have like 2 minutes, and people are getting up. I don't know if we're gonna have time for Q&A. If people need to get to where they're going, although there's 20 minutes in between. If you have very pointed, specific questions, I'll be roaming around. I don't want to cut the legs off of this. I just don't want to hold anyone else up or the person who's coming on after me. So, thank you.